If you've ever thought about going back in time, all you have to do is look up at the night sky. Since the stars, twinkling, there are actually images of the distant past. This is due to the fact that even the light from the nearest of those stars, planets, and galaxies can take tens of thousands of years to reach Earth. Undoubtedly, the universe is a big place. But how big exactly is it? Humanity once believed that the night sky was the unilluminated sphere that enclosed Earth when the sun was sleeping. Prior to widespread development, the stars simply served as the most accurate calendar. When you look at them in the sky, the sun and the moon appear to be almost the same size. But this is really a coincidence, caused by the fact that the sun is both 400 times larger and 400 times farther away than the moon. Even though it seems close, there are 30 Earths worth of space between us and the moon. It would take half a year to get there at highway speeds. However, our star, the sun, is truly enormous. It only appears small in the sky because it is 150 million kilometers away. It would take over 2 years to travel from one side of the sun to the other at highway speeds. The sun is a monster compared to Earth. It is a massive nuclear fusion reactor with enough hydrogen fuel to burn continuously for another 4 billion years. The distances are so vast that a larger unit of measurement is required, which is why astronomers use light years. According to Einstein's law of conservation of mass, the universe's highest speed limit is the speed of light. As you approach the speed of light, the energy required to accelerate increases dramatically. If you could actually travel at the speed of light, your mass would increase to the point where it becomes effectively limitless, requiring an infinite amount of energy to accelerate further. Thus, since light is made up of massless particles called photons, the only thing that can practically travel at the speed of light is light itself. So, by using the fastest thing possible, light, and measuring how far it travels over a given period of time, we have a practical way to measure enormous distances. Light travels from the moon to Earth in around 1.3 seconds. In other words, the moon is 1.3 light seconds away from Earth. The sun's light reaches us in about 8.3 minutes on average. As a result, we always see the sun as it was about 8.3 minutes ago. Mars's distance from Earth changes because it orbits the sun differently than Earth does. We use light minutes rather than light seconds, since Mars is much farther away than the moon. Sending light or radio communications from Earth to Mars takes more than 3 minutes when the two planets are closest together, and more than 22 minutes when they are farthest apart. We say the distance lies between 3.11 and 22.27 light minutes. On average, that is almost 1,000 times farther than the moon is from Earth. The distance to Neptune, our farthest planet, is measured in light hours. Neptune is approximately 4 light hours from the sun. Voyager 1 and Voyager 2 are currently located around 23 light hours and 19 light hours away from Earth. Across our Milky Way galaxy, distances are measured in terms of how many years it takes light to travel. A light year is a unit of measurement for distance rather than time. Light moves at a speed of 300,000 kilometers per second, covering about 9 trillion kilometers in a single year. That's a light year. For example, the star Alpha Centauri is 4.4 light years away from us. A beam of light would take about 4.4 years to travel from Earth to Alpha Centauri. We use light years because they are much more convenient than using enormous numbers like 41.32 trillion kilometers, which is equivalent to 4.467 light years. We are seeing the light that left that star more than 4 years ago and is just reaching us now. Even farther out in space and time are the galaxies. The Milky Way galaxy, where we reside, cannot be fully captured in a single photograph. Therefore, you have never actually seen it. What you have seen are artistic depictions of what we believe it looks like, or images of other galaxies that we believe are similar to our own. From edge to edge, our galaxy spans around 100,000 light years. It would take longer than the age of the entire universe for us to launch a camera far enough outside the galaxy to capture a complete image. Then, it would take many centuries for the radio waves carrying that image to return to us. Andromeda, our closest large neighboring galaxy, is located roughly 2.5 million light years away. We refer to the group of more than 50 nearby galaxies as the local group. This region has a diameter of about 10 million light years. Many of its galaxies are smaller than the Milky Way, while others are larger. Most of them also contain hundreds of billions of stars. At roughly 60 million light years from the Milky Way, the Virgo cluster is the nearest large cluster of galaxies. The light we see today from galaxies in the Virgo cluster began its journey toward us around the same time the age of the dinosaurs was coming to an end on Earth. If you were in a galaxy within the Virgo cluster today and had a telescope powerful enough to study Earth, you would be able to see the prehistoric reptiles. However, as we travel even farther, the Virgo supercluster becomes minuscule in comparison to the Laniakea supercluster, which is approximately 500 million light years across and contains at least 100,000 galaxies. Is that big? No, not in comparison to the observable universe. There are about 2 trillion galaxies in the region of the cosmos that we can observe. Even the Laniakea supercluster appears to be a tiny speck of dust in comparison. The distance to the farthest point in the observable universe is approximately 46.5 billion light years. That is obviously older than the universe itself, which is only about 13.8 billion years old. How is that possible? In simple terms, the universe is expanding because of a process we don't yet fully understand. As a result, the farther away an object is, the faster it appears to move away from the observer. For now, we attribute this phenomenon to dark energy and dark matter. Although dark matter and dark energy have not yet been directly observed in the way ordinary matter has, there is overwhelming evidence that something is causing the expansion of the universe. At its farthest reaches, space itself expands so rapidly that it exceeds the ability of light to cross that expanding space. This means the edges of our observable universe are moving away from us faster than their light can ever reach us. Gradually, these distant regions disappear from view. Beyond a certain distance, light simply cannot travel fast enough to ever reach Earth. As a result, the light-emitting objects in those regions effectively vanish from our observable universe forever. Physics prevents us from looking beyond the observable universe. Whether the cosmos is finite or infinite cannot yet be determined with certainty, but scientists agree that it is unimaginably vast. It's amazing how enormous the universe is, and how much of it we can't even see. But that doesn't stop scientists from searching for answers. Perhaps we may never be able to figure it all out. A telescope allows us to travel through time. Looking out into space is like looking back into the past. It sounds magical, but it's actually very simple. Light moves so quickly that in our everyday lives, it seems to arrive instantly. Yet even at these incredible speeds, traveling across the galaxy still takes time. Gamma rays, radio waves, and every other wavelength in the electromagnetic spectrum are emitted by galaxies. Each of them provides valuable information about the different physical processes occurring within a galaxy. We can observe some parts of the electromagnetic spectrum only with space-based telescopes, because Earth's atmosphere blocks them from reaching the ground. The Hubble Space Telescope was designed and optimized to observe both the ultraviolet and visible portions of the electromagnetic spectrum. The James Webb Space Telescope was designed to observe a broad range of infrared wavelengths. This is one of the main reasons why the James Webb Space Telescope can see farther back in time than Hubble. The influence of dark energy becomes more significant over extremely large cosmological distances. This helps explain why, despite the universe being approximately 13.8 billion years old, the observable universe is about 93 billion light-years across. Within the Milky Way, the effects of dark energy are far too small to observe. However, across immense cosmological distances, its influence becomes measurable. We are living in an incredible era of discovery. Just over a century ago, we didn't even know that galaxies existed beyond our own. Today, we know there are roughly 2 trillion galaxies in the observable universe, opening up an almost limitless frontier for exploration. The James Webb Space Telescope will continue to lead us on incredible journeys through space and time for years to come. And here's some good news for you. If you want to stay up to date, be sure to subscribe to our channel for the latest news about the James Webb Space Telescope, as we bring you the newest Webb discoveries and fascinating insights from across the universe. I hope you enjoyed this video. Don't forget to hit the like button and share your thoughts in the comments below. What do you think lies beyond the observable universe? Thanks for watching, and I'll see you in the next video.